Welcome back. Open your toolkit to page 55. We'll go over the warm-up. This first question, I recommend that you try to do it on your own first, and then pause me and then come back and try it. Number two, it will take the velocity and position graphs to a different level. And this is the type of question that, again, you will be seeing on your assessment. So I would like you to pause this video, try to do number one on your own. And when you're done, come back, we'll do number two together, but I'll still go over number one. Sketch both the velocity and position graph for each one of the following scenarios. The first question is walk quickly from start for 10 seconds, and then stop for 10 seconds, walk slowly backwards for 10 seconds. So this is taking us like a different thing when we're talking about when you're looking at walking slowly backwards for 10 seconds. Let's take care of the first 10 seconds, which is walking quickly for 10 seconds, which is definitely will be a velocity that's higher than walking slowly. So if I pick that this is my verse velocity, 15 miles per second, if I'm walking quickly for 10 seconds, the first 10 seconds, you're stopping for 10 seconds. Recall from from the day before that the velocity graph will appear like horizontal lines. The distance graph will appear like slanted lines, except for when you're stopping, it will be like a horizontal line. Now, when you're walking slowly for 10 seconds, this will be below the x-axis because you're walking backwards. So this is the new thing that you're introduced to this time with this lesson. When you're walking backwards, it will be below the x-axis. So your horizontal line will be below the x-axis. So walking slowly, I'll pick a slower speed than the one that I picked up from the beginning when he's walking quickly. So I can do definitely this one, and this will demonstrate that you're walking slowly. Not only walking slowly, because below the x-axis, it will be below the x-axis, and it would be like, a negative velocity. So the velocity is negative when you're walking backwards. For the distance graph, again, it would be slanted line. So at this point, for the first 10 seconds, you're walking quickly. So it would be a steeper line compared from 20 to 30. When you're looking at the steeper line from 0 to 10 seconds, because you're walking quickly and you're moving forward, it would be a positive slope. But when you're walking backwards, it would be a negative slope. So here, I'll pick this one as my slope. So I have a steeper line, and then I'm stopping for 10 seconds. And I need to pick, I cannot move from this point to this point, from this point to this point here, and say that I'm walking backwards. Again, it will be a negative slope because I'm walking backwards. But this is you're walking slowly. So the slope here will be definitely less than the slope here, than the slope in the beginning 10 seconds. The following question, walk from start for 10 seconds, return to start at the same speed for 15 seconds, and then walk backwards to finish for the 5 seconds. Here, the velocity have not changed, like the speed did not change from 1 minute or from 1 second to another second. So we'll have the same speed all throughout the whole problem. You're walking for the first 10 seconds. So I'll pick, this is my speed. And then I'll return to start at the same speed for 15 seconds. So I'll pick the same speed. So I went down up here 2 units. So I'll go down 2 units for the following 15 seconds. And the last 5 seconds, you're walking backwards, which means like in the end, you're going forward, and then you're walking backwards, and then you're going back again to forward, which means you're going to go forward the last 5 seconds. The distance graph will be like you will look at slanted lines, but at this point also you need to consider that the slope will be the same throughout the whole problem. So you're walking from start for 10 seconds. So I'm going to have the same speed, like, for the first 5 seconds, which just seems like you're going up 10 over 10 or up 1 over 1, if you be specific. The following 15 seconds, you're walking, you're still going down 5 over 5 or down 10 over 10, but you're looking at the 15 seconds. So 1, 2, and 3. So here's my line. For the following 15 seconds, the last 5 seconds, you're walking backward to the finish line. So you're moving back again to the finish line here. For C, they're saying begin at finish, walk slowly. So begin at finish, you're walking slowly backward for 3 seconds. So you're walking slowly, so I'll pick a small speed for the first 30 seconds. So this is my velocity graph. For my distance graph, I'm going to pick a specific distance that I traveled, and I'm going to be walking backwards for 30 seconds. So here we go. The following, this is what the question that you can see, type of question that you will see on your assessment. You will be given a velocity graph and you will change it to a distance graph, and you will be given a distance graph and you want to change it to a velocity graph. The velocity, if this is the velocity graph, the area under the curve will represent eventually the distance that have been traveled. So instead of me going up by 2s, I'll go up by 1. So each one of those units would be 1, 2, 3, and 4. So I'm going to go up by 4 in order for me to fit the distance graph. The area under the curve from the first second would be 4 times 1, which is 4. So I'll go up 4. The distance that have been traveled is 4 miles. Think about it, 4 miles up to here. From 1 to 2 seconds, I have 1. This distance is 1. This distance here is 6. So I traveled another 6 miles. So it would be, I'll go up all the way up to 10. So 4 with a higher speed. So from this one, I'll go out to a higher speed. So it would be up to 10. So up to here is 4. Another 4 is 8. So up to here. So it would be 10 here. So here I have from 1 to 2. This is my slope for the second line. From 2 to 4, there is no motion. So it would be a horizontal line. And then I'm walking backwards, so that means it would be a negative slope, and the area that's under the curve will be 2 by -1, so it would be -2. So up to here I had 10, so I'll go down 2, so it will end up right here. So again, the first distance that have been traveled is 4 miles. 4 times 1. The area under the curve for the first second is 4 times 1, so I went up to 4. From 1 to 2, there was 6 miles that have been traveled because the area under the curve is 6. So I'll move on from this distance all the way to 10. 6 plus 4 is 10, so I'll move up to all the way to 10. From 2 to 4, I'll have a horizontal line. There is no motion, and then the last one, you're walking backwards, so it will appear as a negative slope. And you went down 2. The area under the curve is -2, so you will go down 2, so you will end at this point. The other way around, now you have a position graph and you want to change this one to a velocity graph. Now let's look at the slope for the first one. The slope of the first one, it's equal to, I went down 6, right 3, so the slope is -2. For the second line, I went up 5, right 2, so the slope is 2.5. And the last one, there is no motion, so the slope is 0 because it's a horizontal line. So let's change this one into like a velocity graph. So the slope would be -2 for the first 3 seconds. So -2, horizontal line. And then 2.5 from 3 all the way to 5, it would be a horizontal line, which is 2.5. And the last one would be a horizontal line from 5 all the way to 11. For me, I just feel like the distance, if they gave you the distance graph and you want to change it to a velocity graph, it's easier because you're looking at the slope for each one of those lines and changing them into horizontal lines according to their slope to change it to a velocity. The part that could be tricky is the first one when you have the velocity, the velocity graph, and you want to find the position graph, but everything comes easy with practice. Now I would like you to open your toolkit to page 50. Copy this velocity and speed toolkit. Now with the velocity, you can have like a negative or a positive one, and the negative and a positive one will indicate your indication, but the speed will be also always the absolute value. So your speed will be always positive no matter what, because it takes the absolute value of your velocity. but the velocity could be positive or negative depending on your direction. Copy this one, pause me, copy this one into your toolkit, and then come back to start the first problem in section 932. We'll discuss question 91108 in section 932. An arrow is fired into the air, so the height is found by the equation f of t is equal to negative 16t squared plus 80t plus 5, where t is measured in seconds and f of t is measured in feet. What's the arrow's height after 3 seconds? You need to understand that like this equation represents a distance equation, not a velocity equation. So if this is the distance equation and you want to find the arrow's height after 3 seconds, simply you take the first one. I'll take the 3 and replace it into my equation. So f of 3 will equal to negative 16 times 3 squared plus 80 times 3 plus 5. And simplifying this one, it will equal to 101 feet. So at 3 seconds, the arrow's height will equal, it was in the air up to 101 feet. What's the arrow's height after 4 seconds? So let's check what after 4 seconds. The arrow's height will be negative 16 times 4 squared plus 80 times 4 plus 5. And this is equal to 69 feet. Now the question is, like the arrow was thrown, it went all the way up. At 3 seconds, it was 101 feet above the ground. And then at 4 seconds, it went all the way down to 69 feet. So it means like the arrow's falling down. So using your observations for part A and B, describe the motion of the arrow. The arrow goes up and then falls. So that like, at 3 seconds, it was all the way up 101 feet above the ground. And then after 4 seconds, it was 69. So it means that the arrow is going down. So the arrow goes up and then falls back again down. Calculate the average. So I'm on D at this point. Calculate the average rate of change for the arrow between 3 and 4. What I need to do is I need to figure out I'm trying to do my AROC and my AROC to find the slope of the tangent line at exactly between 3 and 4. So eventually you're not going to do the AROC at this point because they gave you values. You're not trying to come close enough to the 3. I'll do f of 3, which is, we already found this one into A, which is 101. And f of 4, we found this one in B, which was 69. If I want to do my average rate of change, it will equal f of 4 minus the f of 3, all divided by 4 minus 3. So it's 101 minus the 69 divided by 1. And that's equal to negative 32 feet per second. Now, what does this rate tell you about the arrow? So it definitely tell us that because of the negative sign, it tells us the arrow is falling. So here I can conclude that the arrow is falling. Last problem, between 3 and 4 seconds, the arrow was falling down with a speed of 32 feet per second. Negative is just telling us it's going down. Remember, the velocity could be positive or negative, but the speed, it would be always the absolute value of your velocity. The following question, we'll figure out 109. Suppose we want to know the exact velocity at the arrow at t is equal to 3 seconds. So you want to find the speed of the arrow at exactly 3 seconds. In order for us to find the speed of that, of that arrow at exactly 3 seconds, you need to do at this point your AROC and your IROC close enough to the 3. So we're picking 3 and 3 plus h. So I'll do the AROC and the IROC to find the speed of that arrow at 3 seconds. We originally did the f of 3, which was equal to, from the previous problem, it was equal to 101. Now I need to do f of 3 plus h. So I'll look at my back again to the equation that I had from the previous problem, which was negative 16 t squared. So the t will be replaced by 3 plus h squared plus 80 times t, which is the t will be replaced by 3 plus h, and then plus 5. Let's simplify this one further. So negative 16. 3 plus h squared would be at 9 plus 6h plus h squared. I'll do my distribution. So it would be 80 times 3, which is 240, plus 80h plus 5. Simplifying further, negative 16 times 9 is negative 144. Negative 16 times 6h is equal to negative 96h minus 16h squared plus 240 plus 80h plus 5. Now, simplifying further, I have negative 16h squared. I'm adding your like terms, negative 144 plus the 240 plus the 5 is equal to 101. And negative 96h plus the 80h is equal to negative 16h. Now I have all of my work ready in order for me to figure out the AROC and the IROC. So your AROC is equal to f of 3 plus h minus your f of 3 divided by 3 plus h minus the 3. Your f of 3 plus h is negative 16h squared minus 16h plus 101 minus the f of 3, which is 101, divided by 3 plus h minus 3. That's equal to h. Now let's see any like terms I can cancel from the top. The 101 and negative 101 cancels out, leaving us with negative 16h squared minus 16h over h. And your AROC is equal finally to divide each one of the terms by h, or pull out the h as a GCF and then cancel it out with the h that's in your denominator. That will equal to negative 16h minus 16. I figured out my AROC. Now I'm ready to do my IROC, which is my instantaneous rate of change, to find the speed, or the speed that of the arrow at exactly 13 seconds. So the IROC will equal to the limit as h is approaching 0 for this equation, putting the h as a 0, so this whole thing will be negative 16 times the 0 minus the 16, which will end up being negative 16. Now the question is, what's going on with this? What this number represents? Think about it. This number represents the negative 16 is your velocity at exactly 3 seconds. So the velocity at 3 seconds is equal to negative 16 feet per second. But the speed at 3 seconds was equal to 16 feet per second. So remember, the speed will always be the absolute value of your velocity. The velocity, depending on the direction, whether it's going up and down, it would be either positive or negative, but the speed is always positive. The last question of this section will cover 110. Consider this function 2 to the power of x, and for a, you want to find the AROC from 3 to 3 plus h. Again, as usual, we'll find our AROC by trying to find f of 3 first, and it's 2 to the power of 3 to the power of 3. So this is an easy one, and which is equal to 8. F of 3 plus h, I'll replace into this equation 2 to the power of 3 plus h. I do not need to break this fraction, this exponent, into different exponents, but I'll keep it as 2 to the power of 3 plus h. Now I'm ready to do my AROC and my IROC. So my AROC is equal to f of 3 plus h minus the f of 3, all divided by 3 plus h minus 3. I'll start by replacing the values. F of 3 plus h is my 2 to the power of 3 plus h minus the f of 3, which is 8, divided by, simplifying the denominator, is equal to h. And now I'm ready to do my IROC. So your IROC is the limit as h is approaching 0, and you have on the top 2 to the power of 3 plus h minus the 8 divided by h. Now, if I put the h in this equation, right away I know that I'm facing a problem here, because you cannot divide by a 0. I cannot simplify this one further. Even simplifying this one further, it's not going to help me to find my IROC, which is the limit as h is approaching 0. Your only option at this point is to go back again to your graphing calculator, put this equation in your graphing calculator as 2 to the power of 3 plus h minus 8, all divided by h. Now the h is not represented in your calculator, so you will need to replace it by x. So the command will be written in your y equation into your graphic calculator as 2 to the power of 3 plus x minus 8 divided by your x. Now, go to your second window, which is your table set, and change this one to S because I want to come closer and closer to the 0. So now your table will be empty and you will end up, you have to put values in order for you to find what would be the value of this equation when you're trying to come closer and closer to the 0. So if I put 0.1, I will end up with 5.7419, but I want to even come closer and closer to the 0. So I'll put 0.001, and I will get 5.5471. I'll try even to come closer and closer to the 0. So 1 times 10 to the power of -7. And my limit as h is approaching 0, when I'm trying to come to this equation close enough to the 0, it was 5.5452. So there is no actual algebra that will help me to find this value, the IROC, when h is approaching 0. So I'm trying to go back again to my graphing calculator. So what does this value represents? So think about it. If you have this equation and this is 2 to the power of x at exactly 3, so if this is 3 here, if I draw a tangent line at exactly 3, the slope of that tangent line will equal to 5.452. So the slope of this tangent line is 5.542. So if this was to be a word problem, if it was to be a word problem, an application problem, then this would be the speed or the velocity at exactly 3 seconds. But since we do not have an application problem with this one, this would be just, it will represent the slope of the tangent line at x is equal to 3. And this is an important topic to wrap your head around it. What does the AROC and the IROC is representing in any problem that you're doing? So if you take, again, a tangent line and try to touch that graph at that point, which is x is equal to 3, the slope of that tangent line that you just drew, which is right there, that slope of that tangent line is equal to 5.5452. This question concludes today's lesson. I hope that you enjoyed it, and move on to your homework assignment now, and good luck with your homework assignment. Have a great day.